All right, well, welcome everybody to the 2023 edition of the Web Performance Working Group. My name is Nick Jansma. I'm one of the co-chairs of this with Bill over here. We're going to start out today just with a copy of the slide deck that we've been doing for the last 4 or 5 years, updated to today's statistics, to kind of set the stage for the week, talk about some specifics around all the health rules and stuff like that, kind of get off. Without further ado, let's start. Setting context for the week. That's good for review. Our mission statement. Mission is to provide methods and observe and improve aspects of application performance of user agent features and APIs. Basically, make stuff faster and be able to measure this. We've accomplished. I think we've accomplished a lot last year. We'll talk about some of the highlights. We are working on a new charter. We have some new incubations, but we've moved a lot of some of the work that we were doing with preload and resource instance. We've moved it to the HTML spec. We've introduced a new triage process for open issues. So some of you may not be aware of this, but every other week or so, some of the members meet to go through all of the new incoming issues in GitHub. We do a basic triage on them, understand which ones we need to discuss more, which ones we should talk about in the future. Call, and basically just try to get a handle of all the new issues that are being opened, which I think lately we've had a decent amount of new issues being open for us and things that we need to talk about and discuss. As a result, we've actually closed 133 issues in the last year, which is quite a bit. So, yeah. Thanks for all the work and everybody that's part of the discussions, the triage, the commenting, and all that kind of stuff. It really shows a lot of progress over the last year. In case anybody is interested in this deck, you can click on the link and look at all the issues. We are going to be going through a rechartering. So the current charter, which ended in 2023, we have an extension for to wrap it up and get a recharter going. There is a proposed charter which has a few changes from the last one. This one would be then available through 2025. There is a draft up there. It is being reviewed, and there's also a pull request open. For anybody that would like to make comments or open issues, we are tracking it in GitHub, and you can track the charter there and raise any issues or make any comments on the existing charter there. Some notable changes about the rechartering. We will be including event timing within the charter. We are doing a little bit of additional spec unification, and we'll go on the details on that more later. We're hoping to revitalize the primer. So there's a web performance primer that we have it as a deliverable within the working group. It hasn't been updated for many, many years, and we think it's a good opportunity to help evangelize some of the stuff that this group does and better document some of the best practices. And similarly, we have a document around performance APIs, security and privacy, and our approach to those. And we'd like to freshen that up as well with some of the latest thinking and stuff like that. I don't want to go into details about that right now. We actually do have a discussion session scheduled for tomorrow at about 5 o'clock local time to go into the details more of that. So look forward to that tomorrow if you are interested in talking about the charter at all. We have a lot of new incubations that we've been talking about over the last year. Some of the highlights, the unload beacon, the pending beacon, fetchlater. Talking about compression dictionaries, a bunch of updates to resource timing, new attributes that are exposed via that, soft navigation heuristics, updates to nav timing for bimodal distributions of all the different things we're measuring, long animation frames, cross-origin timeline. A lot of stuff that's being developed, discussed, prototyped, experimented with. That's coming, through the WXCG, and we're working on it and stuff within the working group as well, or at least discussing it. So if you are interested in any of those, we love your participation in discussing these. And we are going to be talking about incubations more again as well at the same time tomorrow as part of the rechartering discussion. So we'll dive into that one later. Any questions on anything so far? That way, feel free to ask, interrupt. Happy with that. We do this slide every year. This is a list of all the different things that are being tracked from Chrome's point of view that the working group publishes on, and the adoption by percentage of websites or web navigations? Navigations, where some of these features are being used within the websites. The percentages are the percentages that we just talked about, and then the changing in percentage since last year. So, in general, it seems like our, adoption of a lot of the new technologies that we're working on, the things that we push into Chrome, fairly well adopted across the web. I'm always interested as well in just how some of the changes are year over year. In particular, some on the second list, I'm not quite sure why long tasks is seeing such a strong increase, 18.5% increase since last year in usage. I'm also not sure why reporting observer is down 7%. I don't know if anybody has any insights into any of that, that would be interesting. But, in general, I think a lot of things we're working on here, it's great to see that these are being picked up both by websites and, third-party scripts and that kind of stuff. So pretty cool that we're tracking this and good to see progress. We do have a few new members this year, ByteDance, Vita Corporation, and Skynet. So welcome if you are anybody here. I would actually like to, if we don't mind, kind of going around the room and just everybody giving a very brief who you are, if you want to, what we work for, just so we can all kind of know if anybody's talking later, some of the context. That's okay. So I'll start out with that. My name is Chansma. I work for Apple Technologies. One of the co-chairs, and I'll hand it over to you.
You're working on Google Chrome. What does feedback do?
Alex Christensen, Apple WebKit.
I'm Joshua from Google Chrome. I'm working on network-related stuff.
I'm Shunya from Google Chrome, working on Service Worker.
Karine, the refugee staff contact for the group.
Hello everyone, I'm Sean from Mozilla.
Hi, I'm Benjamin from Mozilla.
Jeremy Roman, Google Chrome, and about 20 minutes we talked about what we're working on. So,
Alexander Google Chrome, same.
So work on electronics at Google.
You're spinning off from Apple.
Ian Cullen, also on Chrome Speed Ventures.
Barry Buller from Chrome Separate.
Michael Mockney, also Google Chrome, on Speed Metrics. I'm focusing a lot on event timing.
And if we go that way, I'll come back around.
Absolutely.
So Andrew, if you could start.
Andrew Dominus,
Sam Weiss, also Meta. Dave Schloss, also Meta. Adam Rice, Google Chrome, Web Networking. Brian Schrock from Meta.
Mohan Cho, Paris Government, Pakistan.
Eric Kinnear and Apple Temper Kernel.
Vicky Raju, Google Chrome, also Web Networking.
Dominic Carolino at Google Chrome. Mark Nottingham, Cloudflare.
Hi, Prashant, I work in Google Chrome and primarily use LinkedIn for graphics stack.
Vlad on Google Chrome.
I'm Antonio from Igalia.
Welcome everybody. Thank you for participating. Yeah, there, let's see. No, would you be able to say hi?
Yeah, can you hear me? Can you hear me okay?
And yeah, Neil. You don't mind saying hi?
Hey, yeah, Neil Craig. I'm lead architect in public service BBC digital distribution.
Hi, I'm Alon Kochba from Wix.
All the remotes that we have participate. Well, thank you everybody for joining. And the remotes for joining, we will try to incorporate you as much as we can. Feel free to speak up, raise your hand, and we do that too. Okay. or otherwise make attention so we can incorporate you into the meeting as much as possible. Thank you. Or leave comments as well if you prefer that way. We're all awesome. Thanks for everybody for participating here. We've got a lot going on, so thank you for coming. We do have the agenda for the week listed at that bit.ly URL. Put in the web perf WG on Slack. I don't know if we've tweeted it out yet, but feel free to grab the link where you can. Today's agenda, we do have listed here as well. Just a brief review of the things that we're going to be talking about today. After this, we'll be doing applicational preloading. Sorry. Okay. We'll be talking about fetchlater after that, and then we'll take a break for lunch. Hour-and-a-half break. Compression dictionaries after lunch. And then the last objective for today, we'll be doing a hands-on workshop for anybody that wants to participate for measuring event timing, long animation frame, and stuff like that. Michael will be leading that. It'll be a good opportunity just to get your hands dirty a little bit. Some housekeeping notes. W3C is committed to maintaining a positive work environment. We all share responsibility for a work environment. We want to treat each other with respect, professionalism, fairness, and sensitivity. Be inclusive and promote diversity. Seek diverse perspectives. Let's try to be conscientious of other people that want to talk. Let's try to pause in our conversations to give the opportunity to other people to talk. A lot of times we're talking very fastly at each other. There may be somebody else in the room that wants to get a word in, so maybe let's try to give a few moments to allow for that. Similarly, many of us love talking, and it would be great to try to get the opinions of others that may not speak as much. There are links to a document on unacceptable behavior and safety versus comfort. Feel free to, well, you should review those as part of the participation here at TPAC. We are recording this session. As a note, we are going to try to record all of the video or all of the presentation portions that everybody is doing here. We would like to not have any comments or questions during the presentation. After the presentation, we will stop the recording and we will allow for comments and stuff like that. Between Yov and I and maybe some other people that would offer to do some of the scribing, we will also be trying to do scribing of the meeting minutes for this entire thing. It is a lot of work. Last year we took like 90 pages of meeting minutes over the 4 days. So if anybody else would like to offer to help or even just monitor our typos and fix those for us, that would be fantastic.
And that's happening inside the agenda doc.
Okay, inside the agenda doc. And then we will publish the recorded part of the recordings within the agenda doc later once we have time to process those videos and upload them. That's the last thing. Maybe that was the last slide. Oh, there we go. Health rules. As a reminder, masks are required at all times, unless you're eating or drinking. Has to go over your nose and over your mouth as much as possible. Please take tests every morning. If you should have been given testing kits when you checked in. If you have any concerns, there is a link on that page for contacting the WSBC staff to give them updates on anything. Please stay isolated if you do become positive or symptomatic, so we can try to maintain the health of everybody here and everybody can travel home safely and quickly when they want to. I think that covers everything I wanted to say. Anything else that you can think of? Okay. Any questions about any of that? Or yes, thank you.
Hi, I'm once again Jeremy Roman on the Chrome team. Dominic. Yeah. We're talking about speculative living, basically how to make navigations go fast by doing stuff sooner. So page load time matters to users, authors, and user agents. LCP, I'm sure most of you have heard of it, is one key way that we measure how long it takes before a page appears substantially loaded to the user. Doing the good threshold is a good baseline, but we know that users and authors benefit even beyond that. There are a lot of things authors can do to accelerate page load already, like optimize their images, lazy load users needed, execute scripts synchronously, add preload hints, early hints, start recording resources sooner, reconnect active domains. But sometimes, just getting a head start is something you want to do on top of that. There are two major things user agent can do to preload the next navigation if it has a hint about where the user is going to go next. It can prefetch the resource from the server or cache, or it can pre-render the new page off screen. Pages may not ordinarily be cacheable, but if they are, then populating a cache does benefit subsequent loads as well. So we want it to be as easy as possible for authors to make this possible on the pages, to understand how to spec their pages, and I think the web came out for APIs to enable the user agent to develop those libraries to assist the author with this. So here's sort of a breakdown of the problem space, both in terms of what developers have to think about and how the spec and implementer concerns are organized. So because prefetch is somewhat simpler, we can do it cross-site and take some extra steps to preserve privacy. Pre-rendering, we've only been working on a site for now because there are a lot more privacy concerns when you're executing arbitrary script. The simplest entry point for these technologies is from a browser feature, the browser UI. But even still, like you use something like the URL bar, for instance. This still has web-facing implications. Site libraries need to know potentially the low speculative, and so we provide APIs to help make it possible for them to distinguish. And in the case of pre-rendering, there are some visible behavior changes that sites may need to be able to deal with, like delaying sound or permissions requiring APIs while pre-rendering, because this is just pre-rendering, the user can be asked to grant permissions or hearing audio or anything like that. So there's a big benefit to this. That browsers can be a lot of value for their users with these browser-driven features, but to speed up the web at large, we need to handle page-to-page navigation. So there's a very large chunk of navigation of the web because we made this wonderful thing called link ages ago. This is where speculations comes in. It's a way of declaratively telling the browser, here's a strategy for prefetching from this page, and here's a strategy you can use for pre-rendering.
All right. And so, Chrome, we've been working on these technologies for a couple of years now. We've showed up at TPAC before to talk about them. Here's kind of an overview of what we've been doing to give some context, right? Like, so we shipped URL bar pre-rendering throughout 2022. We shipped speculation rules, prefetch and pre-render, so that web developers could just start triggering from page to page. And then we expanded, from starting on Android, going to desktop, different types of situations, fixing lots of rough edges, failing pre-rendering on certain APIs, narrowing that list over time, that sort of thing. So far this year, we've really switched our focus to be about how can we kind of get more and more parts of the ecosystem to benefit from these technologies, right? So one of the big things here is we ship good dev tools. We'll have a small slide on that later, but that's been getting good reviews so far. We responded to a bunch of API gaps that partners have found, things like, oh, you need to set the referrer policy, or we need to be able to detect prefetch client side, that sort of thing. And then we're working on expanding URL bar prefetching and pre-rendering to more cases beyond the simplest ones. And then, so, the last column is kind of the stuff that is still ongoing, still in progress. We're working on this no very search header, which we talked about at TPAC last year, which allows you to kind of match a prefetch or pre-render against something that doesn't have the exact same URL because it differs in the search or query params. We're working on document rules, which is a way of declaratively saying like, oh, all links that match this CSS selector or that match this URL pattern, we should prefetch or pre-render those, or at least allow them to be. Delivering these things through headers. And then we have some cool ideas for how to improve the heuristics. Like if you say everything on my page is prefetchable, browser take care of it, what's the smartest thing the browser can do? Maybe it could use machine learning. Yeah. But this is the web performance working group. I know we're all cold-blooded about the numbers here. Like, how much does this actually help compared to all the other options we have? We've gotten some good numbers from a couple of sites and from Chrome itself, and I'm excited to share them. So one of the nice approach one of the simplest places we were able to deploy this is on a relatively first-party site, web.dev. Barry, who's in the room, helped us with this. It's a developer relations site for the Chrome maintained. So it's a relatively simple static site, but it got substantial performance gains for same origin navigations. So when they triggered, prefetch got 200 milliseconds off of the 75th percentile LCP, and when pre-render triggered, it got even further, 700 milliseconds. So you can get like near instantaneous navigations if you're using Chrome on web.dev. It's pretty cool. I advise you to check it out. The way they did this, you can see the code over there, is by using the document rules origin file we're running, where we say wherever it matches this URL pattern, but not ones that match this other pattern. And so I'll mention that this data is not necessarily apples to apples. I'll only go to the next slide so you can see the even cooler data. We got a distribution shift showing the actual percentiles of LCP, and you can see how on mobile it shifted pretty significantly compared to desktop and things like that. So pretty cool. But yeah, as I was saying, it's not based on counterfactuals. It's just comparing like when a pre-render succeeded versus when it didn't trigger, and that can be due to a variety of factors. So like on low-end devices, we don't trigger pre-renders, for example. So this might reflect some of that, but it's still a pretty exciting result to just, looking at the actual change distribution of user experience on your site. I think most sites would be happy to have something like this. Another partner we've been working with is NitroPack. They're in the performance space, and they're currently testing speculation rules pre-render versus their existing link rel equals prefetch solution, versus, of course, pages without any speculative loading technologies. So this has been pretty exciting. So what they do is they insert a specific URL pre-render rule on Hover, and they saw minus 168 milliseconds on the 75th percentile LCP for prefetch. And maybe even more dramatic is, sorry, that's supposed to say prefetch. I think it's supposed to be prefetch versus no. Okay, well, I think it's actually pre-render versus no speculative loading as far as slice that. You get minus almost 2 seconds of LCP versus not doing any loading at all. So that's pretty cool. Right, here's the more full detail that they provided us. This is, they're a pretty substantial provider, and they have a lot of data, but it is still early, so don't take this as perfect. But yeah, these are some pretty big differences. The first column is the no speculative loading technology. The second column is prefetched, and it's pre-rendered. Another cool thing about this slide is it shows kind of the benefits of these technologies for other performance metrics besides just LCP. We won't be touching on that as much throughout the presentation, but yeah, like if you're caring about user layout shifts or input delay, or whether the page responds when you tap on it, these technologies can definitely help. So, all right. Finally, I'm happy to report that we got approval to publicly share aggregate numbers for Chrome itself. So these numbers are for the URL bar trigger pre-rendering that you see in the right hand. So we get the experience that when pre-render triggers, you get negative, you get a 600 milliseconds off of your 75th percentile LCP. And this by itself actually made a 9 millisecond impact on the global average LCP that users experience, which is kind of a big deal if any browser vendors have tried to move that number before. So we're pretty excited to be kind of moving that needle. So there's some interesting stuff here, like URL bar triggered pre-rendering doesn't have a ton of lead time, but we're still seeing this. It's just how long it takes the user to decide, oh yeah, that looks right, press enter. Yeah, I have data in the speaker notes, which you can find from the agenda on the other percentiles, 50th and 95th, that we encountered. And yeah, as you can see, the impact is a little bit less on desktop. But yeah, this is pretty cool. And this is counterfactual analysis data. So this is apples to apples. We turned it off for 1% and compared it to a 1% control group. So this is pretty clear. These are the actual benefits that you see. Speculation rules also is having an impact across the web. So these are, again, 75th percentiles. Prefetch is having another 10 milliseconds cumulative impact on global LCP. When it's triggered, you get this almost 300 milliseconds decrease on Android. And then pre-render has even more dramatic decreases in time when it triggers. It's not deployed at a large enough scale that we really see global LCP movement from pre-render yet, but for those sites that are using it, we're seeing this. So this is again based on counterfactual data where we have a small holdback groups, but there are some biases possible based on which websites are deploying speculation rules so far. So for example, it's a little strange. You might think that the original pre-movement LCP for pre-render is lower than that for prefetch. Well, this is largely a function of which sites have been excited enough to try pre-render. It's the sites that are already kind of fast and are really into performance. And so you're seeing them move that to, from pretty good to really good. So yeah, that's the same thing. And again, I have more percentiles of data if you're interested in the speaker notes. One thing I want to briefly touch on that we kind of saw hinted at by some of those numbers is this core trade-off that we're just starting to explore in this space between these three factors, right? So precision is roughly how often your predictions are correct. If you have higher precision, you have less weight. Recall is how often you predict the correct thing. Higher recall means you speed up more of the navigations. And then lead time is how soon before the navigation we start to prefetch the pre-render, right? And so there is a trade-off here, right? If you predict literally every link on the page, you get perfect recall, terrible precision. You can get arbitrarily large lead time. If you predict on pointer down, you get extremely high recall, very good precision, and low lead time. Things like that. There's a high lead time predictor is to speculatively load the most popular or the most important link on the page, like the top search result or the call to action button. A lot of people are experimenting with hover predictors right now, which have moderate, hundreds of milliseconds lead time, moderate recall, at least on desktop, and moderate precision. And we think we can do better. This isn't a zero-sum triangle, even though I've kind of depicted it as such. We were investigating different ways. As I said, maybe machine learning models that can maximize each of these axes while keeping the other two fixed and similar type of approaches. So another thing you can do is if your site or your platform has access to analytics data, you can use those to boost what you get, try and keeping a high precision while maximizing lead time, that sort of thing. So, it's worth keeping this trade-off in mind when you're deploying on your site. And, when you're looking at the previous data, right, you might be surprising that pre-render doesn't immediately cause your LCP to go to 0 or to 200 milliseconds or whatever, because it's supposed to be instant, it's rendering in the background. Well, but if the user is typing in the URL bar and, we've finally made the prediction and then they're like, yeah, that seems right. That's not too much lead time, right? It's not the entire lead time that you might need to render the whole page in the background. So,
yeah. All right. So this is part of this talking about clearing some hurdles to documents and stuff that we can working on. So there are some complications even with prefetch. So one thing that we ran into is some search parameters. We talked about this last year if you were here last year. Do not affect the semantic meaning of the resource. So these parameters instead carry information intended for analytics packages or that affect server processing or are insignificant in other ways. So for instance, the order of query parameters is very often does not affect how the search picks the result, but in theory it could. So as a result, we'd still like to be able to use the prefetch for semantically the same resource when navigation occurs, that only varies in those ways. And so in order to this response header that the Chromium prefetch can in this respect, it's a no vary search, very simple no vary query, and then we have setting the base code to be called. And you can specify a list of parameters or all of them that are not significant in terms of whether it matters, as well as you can specify the keyword that doesn't matter. Related to that, when a prefetch is going out or a resource, and then the user navigates before that prefetch complete. We want to allow the fact that you've already started that prefetch still to use that lead time that we've got there. And this URL that is being prefetched and the URL the user is navigating to are exactly the same. We know that we have a prefetch ongoing for that, and we just wait for it. The tricky thing is when the response will come back with a no very search that will allow it to match. We can't see the response headers before the server comes back with us. So there's speculation rules have in accordance expect no very search, which allows the object to declare that they expect this response to come back with a particular no very search. This doesn't affect the ultimate behavior when the response comes back, but it does tell the user agent if this no very search policy would make the resource match, we should probably wait for the resource to come back rather than starting a new request. So it's a little bit subtle, but it ends up not being a ton of extra actual complexity. And working with the Google property to try this out, and we found this API to be fairly easy to use and expressive enough to allow us to use prefetch pages in more cases. One that's a little bit that's a product that we haven't settled on a resolution for yet is user state. So prefective, if they're not cacheable, are intentionally short-lived, reduce the likelihood of stale state, but it is still possible in the order of minutes for a user to log in or log out, or otherwise make some significant change to the state and see an old prefetch page if the prefetch occurred before that state change occurred. Ideally, these should be discarded when this changes. For example, if a particular cookie changes when the user logs in or out. And trying to figure out how can we indicate that that happened. There's a few sort of ideas that have been tossed around. One was to use the HTTP variant proposal, which when I looked it up, it was told me it was the state of it had changed, but in any case, that or something analogous to that, basically some sort of header that says this resource varies on this particular cookie, the value of this particular cookie, or something like that. This varying on cookie in general is probably it's probably going to be overmatched because there are a lot of sites that have cookies change frequently in ways that don't semantically change the meaning of content. Or maybe the page should declare that it's same site or same origin prefetches should be discarded if a particular search changes. Maybe it should be a property of that instead or something else. Certainly would welcome ideas. And then one other thing is this is speculation rules provided by a script element, but for cases where the origin server or reverse proxy is authored or operated by a different group of people than the document, or whether that's a different like department within the same company, or it's a different like a service provider or a middleware provider, we've heard that they would appreciate the ability to ask officials without needing to modify the document content itself. And so we can experimenting with a response header that just provides a URL to flow from. And that way, these middleware providers can inject this in a somewhat less invasive way to the content. Which also sidesteps some of the usual issues you have with modifying hardware around content security policy and other process scripting implications. Other things that authors need, they want to be able to know whether their page is prefetched or pre-rendered. That's how we were able to get some of the numbers that Dominic shared earlier. So for prefetch, you can tell that your document was prefetched by checking the delivery type in the resource timing entry. And on the server side, if a request is being made with the intention of using the prefetch, the set purpose header will indicate that. Pre-rendering is a little bit more complicated because the state changes over the lifetime of script. So you can get there's a document pre-rendering boolean that tells you whether the document is currently being pre-rendered. There's an event which tells you when that changes. And after it has happened, the resource timing is updated to mark the timestamp at which the pre-render was activated. So after it stopped being pre-rendered, it is now being displayed or or does that stuff happen? It's no longer being pre-rendered. And when we do a prefetch of intent for pre-rendering, that is shown as a parameter to the server as well. So this allows authors to identify what's happening and need to modify the behavior of their page. It also allows libraries and packages that do analytics to identify that this has happened and to slice data appropriately. We're also rolling out, we have developer tool support, allow authors to better understand which links are marked as eligible for speculative loading and what the status of that is. These tools should make it easier to understand what's going on as authors try out these technologies. It's definitely one of those things that we've noticed and the people we've worked with have noticed that like it can be difficult to figure out why something that happens in the background isn't working. Whereas having developer tools that show you here's what's going on, here's what the user agent decided to do, is something that we found even more helpful, I think, than we originally anticipated. So we're really excited about that too.
All right, and then, yeah, just to wrap things up, some call to actions, right? Like browser vendors, we should consider implementing this. Your users will thank you for the speed. But if not that, at least consider engaging on the specification. We'd love to get more of your feedback. Ideally, we move these specs into HTML instead of they're currently all living in WCAG or YCG. Web developers and platforms. You should add speculation rules to your page. You can start small. If you're following best practices and your gets are idempotent, you can just easily mark up everything as safe to prefetch, and you'll get a quick, easy win. And if you want to go the extra mile, you can try and make sure your pages are pre-render ready, and do that, or be more aggressive, pick out or use analytics data to pick out the best routes. But it's time. I think these features are more or less ready to deploy, and we'd love to hear from you if you find ways that they're not. And then finally, I know we have some ROM and analytics platforms in the room. Please make sure you update to account for pre-render. It's a reasonable chunk of traffic from these browser features like the Chrome URL bar already. Not sure who's talking, but yeah, just to finish that up, one of the hardest things we've heard from partners about adopting pre-rendering is that they're not sure all of their third parties are updated. This is especially an issue for analytics. We did manage to upgrade Google Analytics, and we know some other analytic platforms beat us to it, but not everyone is there. So the more we can get that, the better. All right, and I think we do have some time for questions. So.
Thank you. And
We're going Minging, the floor is yours.
So, Mingying, I think, is going to present, right? Mingying, are you speaking? I can't hear anything.
No one is speaking.
You are muted.
Oh.
Let me see what's going on here.
Okay, better.
Yeah, that was for yeah. I muted in Zoom, but it's still
yeah. I can't tell if his lips are moving like that.
I'll look it up.
No, Phil can't hear you.
I need to, Can you guys hear me?
Yeah, I can hear you.
Okay, so perhaps I will start off then. I think I'm not sure. Mingying, you can keep trying to. Yeah. So then, should I present or will you present? Let me think. Let me just. Let me get the presentation. Okay. Well. Okay. So. Okay. I'll speak. So Mingying has been doing all of the work on this, but there's been a lot of work. Noam as well, and Noam Rosenthal and Anna have been hammering out the spec. We're pretty close to going for a second origin trial. So I guess let's maybe go to the first slide. So just to be clear, beaconing is sending some data out to the server without expecting a response. There are a couple of ways to do it already, but they have problems. And so we wanted to add another API that kind of ends that. We don't want people sending using fetch in the unload handler. And also it turns out to be quite unreliable. It often doesn't run on mobile, so it's a bad choice in general. And then the send beacon, navigator send beacon is deprecated also. So typical use case is analytics data sent at the end of the user's visit to the page. There's no best time while the page is alive to send this. So you kind of want to keep accumulating data and then have your last version of the accumulated data be sent. And you'd like it to survive. You'd like it to be sent even if the page crashes, for example. That's something that none of the existing APIs can do. So let's go to the next page, I think. So I want to provide a reliable mechanism for delaying operation until the page is unloaded. So that means you don't send it until the page is gone. And that includes being able to go into BF cache, and then when the page is finally evicted from BF cache and is definitely not coming back, it would be sent as well. We want it to behave like a keep alive fetch request. So if what that typically means is that, implementation wise, even if the process that is hosting the renderer, the JavaScript engine that made the request, even if that process goes away or is ready to go away, the request continues working. It doesn't just end just because the page is finished. We want a way to say, if I go into BF cache or somehow are unable to run JavaScript timers, so unable to run JavaScript, and for example, to have timers fire on time, then please send this page, or please send this beacon. So you might say, well, you don't want to wait till the page is fully evicted from BF cache, because that's 10 minutes on Chrome. It's 45 minutes, I think, on Safari and Firefox. You might say, if I'm in BF cache for 5 minutes, I want this to be sent. And then we want a way to be able to update the data. So you might be accumulating data. And so you might have counters and they're getting higher and higher and higher. You don't want to send a request and then send another request because you added one to your counter, and then send another request because you added one to your counter. You'd like them all to just go as one single piece of data at some timing that is good for you. So maybe we'll go to next page. So, okay, we did have a quite different API the last time we were presenting. And then we have really kind of focused on trying to make this reuse as much of the fetch API as possible. So there's a fetchlater call, and it takes a request info, which is the same thing that you would give to a fetch. And then it takes a deferred request in it, which has the extra stuff that we need, or you might want to add to a deferred request, a fetchlater request. And then it gives you back an object which you can use to tell whether the request has actually happened or not. The browser is kind of, free, or it can send things, you might be in BF cache when it's sent and stuff like that. So you have to, if you want to like update the data that you want to send, you have to check what to see. You might need to check whether the previous one was sent, especially if you're accumulating. You might want to just send, the difference between the one that was sent and what you have now. So the terminology, we say the fetch is activated when it basically kind of irreversibly goes into a mode where it's going to send. So that happens when the document is destroyed, or if you've given us a timeout, it could happen when the document is backgrounded or in BF cache, or somehow you're no longer in control with JavaScript and some time has passed. We will activate the request. So let's go to the next page. Okay, so this is looking at the fetchlater result. So yeah, this is what, sorry, I've kind of went ahead of the slides a little bit. It has an activated field, and it tells you whether it has been sent. And up until then, if you observe that this field is false, then you can cancel the request. There's a way you cancel it. Maybe it's in a slide that's going up, so I won't skip ahead. But basically, as long as you observe that this is false, you have an opportunity to cancel the request, and that cancellation should be honored. Once you see that this is true, it's too late to cancel. It has, well, you don't know how much, whether it's fully sent or how much of it has been sent, but you just know it's too late to cancel. So the options that you can give, the way to cancel it actually is the same as a fetch. You give it an abort controller, and you use the abort controller to abort the. You give it an abort controller signal, I think it is, and you use that to abort it. So what the extra options that you can give to a deferred request are the background timeout. We'll talk a lot more about the timeout later on, so I'm not going to say a whole lot about it, but basically it's not a strict timeout. It's basically telling the browser that you'd like it to be sent. If I've been in BF cache for 3 minutes, you should send this. There's no particular guarantee that it will be like sent at like exactly 3 minutes or 3 minutes and 5 seconds or whatever, right? But yeah, it's a best effort kind of a thing. So next slide. So here's an example of how you would right now maybe send a request, a beacon, when a document is discarded. So you might add a page hide listener and send it when the page hide event fires. This is pretty reliable. It works on mobile and on desktop. However, you might send more than once because the page might go into BF cache and come back out, and you could send again. Also, many pages on mobile don't ever get a page hide signal because the browser, someone can put the browser in the background, and then your process gets killed by the OS or by the user, and page hide never happens. So if you really want your data to get there, you kind of have your last chance where you have a really good chance of actually making sure your data gets there is visibility change. When the visibility state changes to hidden, you can send your data. But of course, that's also maybe like far too early, right? The user may come back within seconds, and you end up sending data too early, right? So the with this API, you can just say fetch later, give it a URL and some options, and your data will definitely be sent. As long as the browser process isn't killed, your data will be sent. And with the timeouts and what have you, you can control the timing of when it's sent if your JavaScript stops running. So sending on document backgrounded. So this was it's just another example of basically, this time it's an example that uses the background timeout, but I'm not actually sure what specifically Mingying wanted to call out on this page. So, but you can see basically that you can set a background timeout of 0, and what will happen is at the moment in the current spec and implementation, background timeout triggers from page hide, from entering BF cache basically. So kind of the equivalent is if the page hide event says it's persisted, then you would send with your navigator thing. So I'm just looking at some more of this code to see what I can say about it. Oh, so this is, yeah. So this code here is because, especially on mobile, when you get a visibility change event and you get and the state goes to hidden, JavaScript can stop running. So I did some tests on Firefox. About a minute later, I believe, JavaScript becomes like passive. Timers stop firing. On Firefox, it's about 5 minutes. Sorry, on Chrome, it's about 5 minutes. On Firefox, it's about 1 minute. And so this is a way to deal with that. As when visibility change happens, you set a thing saying background time at 0, and hopefully, that will still fire if the page gets BF cached. Mingying, is that right? Yeah. Okay. So anyway, this is just a couple of examples of before and after, although they're not entirely equivalent. And then this is an example where, you want to send 1 minute after you enter BF cache. I guess the previous one, sorry, the before of that doesn't really work because the timer cannot. The timer cannot fire while you're in BF cache, so that just didn't really work. This is a kind of a new feature to be able to send something after a minute, even though you're in BF cache. Let's go again. Oh yeah, and this is just this is how you set it up so that you can cancel one. So you set it up, and then sometime later you realize you want to send different data, or you want to just not send it at all. So you check, has it been activated yet? If it hasn't, you can abort it, and then you could, for example, start a new fetch with some updated data. Update. Okay, so this is an example of updating some data. It's a little complicated because you have to be careful about the races, and so you need to keep the result around. You need to keep the abort signal around, and then you would probably wrap this up in some kind of an object, maybe. But there's a function here for creating a beacon, and then for updating it. So background timeout is capped by implementation. I'm not sure this is like this. I think we leave it up to the implementation for what's the maximum timeout you can put, I guess. And each implementation has their own like kind of maximum background time, like the maximum time we leave a page in BF cache. So it makes sense for the implementations to just use their own values here. Per document, you can have 64 KB of deferred fetch content waiting to go out. If a new request is made that pushes you over the limit, it's rejected with an error. Is there code coming up that shows how that works? It's rejected with an exception, right? I think, yeah, okay. You can't use streams for this, and we have a kind of an issue here, the network privacy issue, that if you've gone into the background, if we then send one of your network requests later, it can reveal some information that you wouldn't necessarily want revealed. So basically, if you're at home and you're browsing site A, and you go and it has queued a deferred request, and it's going to send in 15 minutes or something like that, and you go to work, and the request sends, and now you're on your office Wi-Fi. Maybe you've just sent a request to something that the people who run your office Wi-Fi wouldn't like. And so we have we want to kind of avoid that unless the page or the site already has permission to do that kind of thing anyway, with background sync or service. I forgot I can't think of the word. Service workers. So if they could be there anyway, well then there was nothing stopping that kind of thing happening in the first place. So there's not much point in us stopping it in this API too. So if background sync is on, then if the page goes into BF cache, we will wait until the timer fires before sending the information. If you don't have background sync on, then we kind of have to send it as soon as you navigate away. Otherwise, we could kind of break this implicit promise. But there's some other conditions, like if you already have like 2 other tabs with the same site open, then we can wait. But if you have no other tabs for the same site open, then we kind of, even though the page has requested a delay, we have to send it immediately. Can we go on? Yeah. So is this just throw it open for questions, Minging? Was that the? Oh no. Okay. Well, yeah. So there's one other. Oh, is your mic working now? No. Okay. There's one other thing. So there's one issue is, for example, the timeout. So there's a couple of issues with having a background timeout versus just a general timeout. And one of them is, like I said, when the page becomes hidden, when the visibility changes to hidden, JavaScript continues to work and timers continue to fire for a little while, and then they stop. And there's no event, at least I don't think there's any event that marks this stopping. And so it is impossible to reliably send your data, say you want to get some data back from the page within 5 minutes of the start of the page load. And then the user puts your page in the in the background after 3 minutes, and your timer that was going to go off on the 5-minute mark just doesn't fire. So this is unfortunate. It seems to be, I didn't test Safari. I don't know whether Safari also has a behavior like this or not, but Firefox and Chrome do, which means that even though the background timeout gives us this extra power that was previously unavailable to send while in BF cache, it doesn't actually give you the ability to reliably send this request at within any particular time. So that seems to imply that we actually need just and also with the background timeout, the code to handle it is quite complex because you would use a set timeout for first, but you'd have to listen to all of the events that could possibly cause you to lose control. And when you do get one of those events, you have to switch. And instead of doing a fetch later with no timeout, you have to cancel the existing fetch later. You have to start a new one with a background timeout. And then maybe when it comes back, you want to cancel that and switch back to an untimeouted fetch later, etc., etc. So it's a lot of work. I think it's ergonomically, it is definitely much easier to just have a timeout that could fire at any point, whether you were backgrounded or not. But also, I think it actually is impossible to build reliable timers in JavaScript currently that will fire, that will deliver your beacon at the timing you want. So, yeah. Does anyone?
So yeah, maybe I can stop the recording and we can discuss those open questions as well as others.